Last class we have learned some problems from the exercise 1.4. We have completed first unit. Today we are going to learn a second unit, algebra. From the algebra we are going to learn first exercise today. And this we are going to learn, in this video we are going to learn what is rational expression as well as partial fraction. How to resolve the given expression as a sum or difference of two or more expressions. First we should learn what is rational expression. An expression is of the form p of x divided by q of x is called a rational expression. An expression is of the form p of x divided by q of x is called a rational expression. Based on the degree of the numerator as well as denominator, there are two types. First one, proper rational expression. The second one, improper rational expression. First we should know what is proper rational expression. If the degree of the numerator is less than the degree of the denominator, if the degree of the numerator is less than that of the denominator, then the rational expression will be called as the proper rational expression. The second one, improper rational expression. If the degree of the numerator is greater than or equal to that of the denominator, will be called as improper rational expression. Here the improper rational expression can be expressed as the sum of integral functions as well as proper rational expression. And improper rational expression can be expressed as the sum of integral function as well as proper rational expression. For example, suppose if I have an improper rational expression p of x over q of x, it can be expressed as the integral function like f of x and proper rational expression. Now we will move on to the partial fractions. Partial fractions. Okay. The process of writing a single rational expression as a sum or difference of two or more simple rational expression is called splitting up a partial fractions. The process of writing a single expression as the sum or difference of two or more simple rational expression will be called as a partial fractions. Here in this exercise we are going to do three types of problems. First type, a denominator contains non-repeated linear factors. If the denominator contains non-repeated linear factors. First type. In the rational expression p of x type 1, first we are going to learn what is type 1. In p of x, in the rational expression p of x divided by q of x, the denominator q of x is the denominator q of x is the product of two or more non-repeated linear factors. X or x plus b into cx plus d. Then the rational expression p of x divided by q of x can be resolved into a the form ax plus b into cx plus d, then the rational expression p of x by q of x can be resolved into partial fraction of the form a by ax plus b plus, here we can take b by cx plus d. For example, now I'm going to give one example for a type 1. Suppose if I have 3 by x plus 1 into x plus 2. Now look at the denominator. Here we are having non-repeater linear factors, so it can be expressed, it can be resolved into a partial fraction of the form a by x plus 1 plus b by x plus 2. Now I am going to give one more example. Suppose if I have 2x plus 1 divided by x minus 7, x minus 2, x plus 1. Suppose if I have a rational expression like this. Look at the denominator. Here we are having 3 non-repeated linear factors. So this rational expression can be resolved into a partial fraction of the form a by x minus 7 plus b by x minus 2 plus c by x plus 1. Now let us move on to the type 2. Type 2. What's our type 2? Denominator contains linear factors repeated n times. Denominator contains linear factors repeated n times. Our type 2, denominator contains linear factors repeated n times. In the rational expression p of x by q of x, if the denominator q of x is of the form, in the rational expression p of x by q of x, the denominator q of x is of the form ax plus b whole power n, then the rational expression p of x divided by q of x can be resolved into a partial fraction of the form a1 divided by ax plus b whole power 1 plus a2 by ax plus b whole power 2 plus a3 by ax plus b whole power 3. Similarly it goes on up to an divided by ax plus b whole power n. This is our type 2. Now I am going to give one example for type 2. Suppose if I have x by x plus 1 whole power 4. Look at the denominator. Here we are having linear factors repeated 4 times. So this rational expression can be resolved into a partial fraction of the form. Here we are having power 4. Here the denominator contains linear factors repeated 4 times. So it can be written as a by x plus 1 power 1 plus b by x plus 1 whole power 2 plus c by x plus 1 whole power 3 plus d by, we can take capital D, d by x plus 1 whole power 4. Suppose if I have like this term can be written as a by x minus 3 whole power 1 plus b by x minus 3 whole power 2. I'll give one more example. Suppose if I have x by 3 by x plus 2 whole power 3. This rational expression can be expressed as a by x plus 2 whole power 1 plus b by x plus 2 whole power 2 plus c by x plus 2 whole power 3. This way you can do the type 2 problems. Then we will move on to the third type. We are going to learn third type of problems. Our third type will be denominator contains quadratic factor which cannot be factorized into linear factors. And this, in the linear fraction or in the rational expression p of x over q of x, if the denominator q of x is of the form ax square plus bx plus c, which cannot be factorized, then the rational expression q of x by q of x can be resolved into partial fraction by taking the numerator as ax plus b. For example, suppose if I have x plus 3 divided by x square plus 3. In this, look at the denominator. Here we can't factorize this denominator. So, I am going to resolve this as this rational expression can be resolved into a partial fraction is of the form ax plus b by x square plus 3. In this term, look at the denominator. Here the denominator cannot be factorized. In this method, I am going to resolve this into a partial fraction by taking the numerator as ax plus b. Okay. Now, based on these three types, we are going to do exercise 2.1. It's very important exercise. Surely there will be questions, some questions from the exercise 2.1. Look at your book. Exercise 2.1. We are going to do exercise 2.1. We can do the first problem. 3x plus 7 divided by x square minus 3x plus 2. Now, look at the denominator. Here we have it a quadratic polynomial. No, it can be factorized. So, first I am going to take the denominator x square minus 3x plus 2. Okay, now I am going to factorize this. So the factors will be x minus 2 into x minus 1. Now I am going to rewrite the given expression as 3x plus 7 divided by x square minus 3x plus 2 as 3x plus 7 divided by, instead of this I am going to write x minus 2 into x minus 1. Now look at this. Look at the denominator. Here the denominator contains linear factors, non-repeated linear factors. Here the denominator contains non-repeated linear factors. So this is the type 1 problem. So I am going to resolve this expression into a partial fraction of the form a by x minus 2 plus b by x minus 1. Now this is equal to 3x plus 7 divided by x minus 2 into x minus 1 equal to, now I am going to take the LCM as x minus 2 into x minus 1. Now I am going to do the cross multiply. We can go for the cross multiply because the denominators are different now, so we can go for the cross multiply. So a into x minus 1 plus b into x minus 2. Look at the denominators. Here the denominators are same, so it will get cancelled. So what's the remaining? 3x plus 7 equal to a into x minus 1 plus b into x minus 2. To find a. In order to find the value of a, the b term should become 0. In order to make the b term as 0, I am going to put the unknown x as 2. 2 minus 2, 0. So it will become 0. So I am going to put x equal to 2. I am going to put x equal to 2. So 3 into 2 plus 7 equal to a into 2 minus 1 plus b into 2 minus 2. 6 plus 7 equal to a plus 0. So the next step would be 13 equal to a equal to 13. Our a is 13. Now I am going to find b. To find b. In order to find the value of b, the a term should become 0. In order to make the a term as 0, I am going to put the unknown x as 1. Put x equal to 1. Put x equal to 1. So we can consider this as equation number. You can consider this as equation number 2. You can consider this as equation number 1. Now I am going to put x as 1 in the equation 2. So what will happen? 3 into 1 plus 7 equal to, this term will become 0. So b into 1 minus 2, that is minus 1. So 10 equal to minus b. B equal to minus 10. Now I am going to substitute a as 13 and b as minus 10 in the equation 1. So what's our What's our equation 1? 3x plus 1, 3x plus 7 divided by x minus 2 into x minus 1 equal to a. What's our a? 13. 13 by x minus 2 plus b. What's our b? Minus 10. Minus 10 divided by x minus 1. So plus into minus minus. So 13 divided by x minus 2. X minus 2 plus into minus minus 10 by x minus 1. This is our required answer. Here we have resolved the single expression as the difference of two simple rational expressions. That's it. Now we are going to do the second one. Look at the second one. What's the second one? 4x plus 1 by x minus 2 into x plus 1. Up. Look at this. Look at the denominator. Here we are having non-repeated linear factors. So this sum also based on type 1. We are going to do this sum based on the first type. Now I am going to rewrite this as a by x minus 2 plus b by x plus 1. Here you can take this as equation number 1. Now 4x plus 1 divided by x minus 2 into x plus 1 equal to, here we can take the LCM as x minus 2 into x plus 1. Here the denominators are different also, we can go for the cross multiply. So a into x plus 1 plus b into x minus 2. Look at these two denominators, they are same, so they will get cancelled. So what's the remaining? 4x plus 1 equal to a into x plus 1 plus b into x minus 2. Here you can consider this as equation number 2. Now to find a, in order to find a, the other term, the b term should become 0. In order to make the b term as 0, I am going to put the unknown x as 2. 2 minus 2, 0. So it will become 0. So in order to find a, put x equal to 2 in equation number 2. So the equation 2 becomes it will become 0. So no need to rewrite. Our A is 3. Array equal to 3. Now look at the equation 2. To find b, in order to find b, a term should become 0. In order to make this a term as 0, I'm going to put the unknown x as minus 1. If I put minus 1 over here, the a term will become 0. So I'm going to put x as minus 1 in equation number 2. So the next step would be 4 into minus 1 plus 4 into x instead of x, I'm going to put minus 1 plus 1 equal to, this will become 0, so no need to write. So b into minus 1 minus 2. Now minus 4 plus 1 equal to b into minus 3. So it will become minus 3 equal to minus 3b. Minus minus will get cancelled, 3 by 3. So it will get cancelled, b equal to 1. That's it. We got our required values a and b. Now I am going to substitute a as 3 and b as 1 in the equation of 1. So 4x plus 1 divided by x minus 2 into x plus 1 equal to a. What's our a? 3. So 3 by x minus 2 plus b. What's our b? 1 by x plus 1. That's it. Now we got the required answer. Now we are going to do the third. The third sum is based on type 2.